This is the third principle of object-oriented programming, and the main thing it brings to the table is that it allows us to reutilize a lot of code, and even though we reutilize it, it also gives us like some flexibility. We're gonna look into an example to show what I mean by this. So here we have a dog object. A quick reminder, it's just a very simple program. If the dog is hungry, it will print dog is hungry on the screen. Dog is barking, sorry, and if it's not, it will print dog is sleeping. It's a very simple, silly program. Now suppose we want to make a cat instead of a dog, and the cat is gonna be like very similar to the dog, but not quite the same. It's gonna have some differences. For example, it's not gonna have breed, and it's gonna have a new method called Uml, for example. So now we could go ahead and create a new object just for cat and repeat all this code. But a better way of doing this would be if we could have some common class that contains all the common data for both dog and cat, and also all the common behavior for dog and cat, and then have dog and cat somehow inherit that behavior and data. So we're gonna do just that. So here's a UML diagram. Even though I haven't explained it, it's like very intuitive, so just follow me around. We're gonna create this common class that we were talking about, which we're gonna call animal, and we're gonna refer to as parent. And this is gonna have the data that's it's gonna be common to dog, cat, and any other animal for that matter. And also the behavior is gonna be common to dog and cat, which is gonna be print and hunger. So that's where the reusability of code comes from, what we were referring to at the start of the video. The reusability of code comes that we write the code once and we can use it several times on different subclasses. By the way, these classes that inherit from the animal parent, we're gonna refer to as childs from now on. Okay, so that's reusability of code. Next comes flexibility. What do we mean by flexibility? Well, imagine that on dog we want one additional field that the parent does not have, in this case breed. Well, we can declare it. So this breed field will be available for dog but not for animal or for cat. And we can do the same for behavior. So on this one we are declaring this new method called meow for cat. Likewise, dog won't have that, animal won't have that, cat will have it. And finally, we can also overwrite existing methods from the parent. So in this case, we can overwrite hunger because we want this method to be slightly different for some reason. Well, we're designing it that way to show us an example. Yeah. Okay, so this is the theory. Now we're gonna do it in practice. We're gonna create our common class, which we refer to as the parent animal. Also, I'm gonna put it on package animals. Okay. And here I'm gonna put all the common data to dog and cat, as we were saying. So it's gonna be the text. Note that I'm making this protected rather than private, because I want it to be accessible on the children classes. Okay, this is the common data, and now the common behavior. I'm gonna make the constructor and the hunger method. I take the liberty to copy it from here because it's very similar. Okay. Protected, so we can use it on the subclasses, the child. Okay, and that will be it for animal. Now we're gonna create the dog. I'm gonna delete this because we're not gonna use it anymore. This is from the previous video. And we're gonna make this dog inherit all the data and the behavior from animal. And we do this with the following word extends, and then the name of the class that we want to inherit the data and the behavior from, in this case animal. So now dog is gonna have access to text is hungry, print, and hunger because we made them protected. It's gonna inherit all the data and behavior from animal. Now we were saying that we wanted one additional data here, so print, we're gonna declare that. I'm gonna make it private. You can remember all the data should be private by default. Well, in this case I took the liberty of making it protected. I could have also like made setters and getters. And the behavior, we're gonna make the constructor. Yeah, this is one peculiarity. The constructor does not get inherited directly. You need to declare it yourself. Okay. One thing to note here is that by default it's gonna call the super constructor, but since it's empty, it doesn't matter if we put it or not. Like by default, it's gonna this is gonna be on the constructor. We just don't see it. Okay, so that's the data and the behavior. And now we also say that we want this to overwrite hunger, and to do that we just put this annotation overwrite and then the method with the same name. Forgot to make this public. This one should be public as well. Okay, and instead of this, we're gonna make this slight modification where we include the breed of the dog. Okay. Okay, so that's for the dog. Next, we're gonna do it for the cat. Again, very similar scene. Extends from animal. There is no additional data that we want, so this is gonna be empty. And for the behavior, we're gonna make one constructor. Okay. Again, remember it calls the parent constructor by default, the empty parent constructor. And then we say that we wanted one additional method particular to cat, which is gonna be meow. All right. So now we have all this structure that we talked about earlier. Let's test it out. We need to import dog and cat. Okay. Okay, let's test hunger first and then meow. So what's gonna happen here is that hunger first is gonna come to animal, but since dog is overwriting hunger instead of this, it's gonna run this piece of code, okay? And on this one, since cat is not overwriting that method, it's just gonna call the parent one. So let's test this out. Gonna hit run. Compiling. Okay, so here we see Husky is sleeping. This is the first one. Animal is sleeping. This is calling the parent one. And then cat.meow is gonna call cat, which is particular to cat. If we try to do something like dog.meow is gonna give us an error because dog does not have that, and same for animal. So yeah, that's the main gist of inheritance. With inheritance, we have code, reusability of code. So for example, if I change this to uppercase, this is gonna get passed down to all the children class since they all inherit this. Quick test. You'll see that it's all uppercase, right? So that's the first thing, reusability of code, and the second, flexibility at the hour of reusing the code, because here we can have like, you know, different method, new data. Okay, so yeah, that's it for inheritance. Next we'll look into polymorphism.